Good morning, students. In this presentation, we will be studying basics of signals and system and classification of signals. Main objective is to introduce this particular subject as a course and then classification based on some fundamental characteristics associated with signals. So, as far as signals and systems is considered, it has its own long history and continuous developments took place in this particular field. Some basic techniques and fundamental principles which are covering extremely broad areas of applications is the main feature of this particular course. The field of integrated technology and its application is continuously growing, due to which study of signals and system also opens up a whole new era of solutions to many latest signal processing problems. As high-speed computational machines are now available for processing, the concepts and techniques allied with signal processing field assumes more versatile approach. Signals and system is the fastest developing field and its application areas are wide ranging. So it becomes imperative that one must learn thoroughly with the integrated approach the basic concepts of signals and systems. Advances in technology are improving capabilities of analyzing diverse information sources such as audio, speech, acoustics, music, or in the form of visual data like images or videos or multimedia or medical related some data samples, or even the signals associated with some biomedical applications in the field of biomedical engineering. There are a number of applications in the field of remote sensing data, then communication, cellular network, computer communication, embedded system, uh, system design. So many more. Like there is no limit, because signal is something which is a basic element of any process or any system. When we design, we have some sort of input, we have some sort of maybe controlling signals, and then the respective output. It may be one to one or one to many or many to one or many to many. So whatever may be the category, with feedback, without feedback, uh, anything it may be, but it is associated with signals. So that's why it is very important to study some fundamental principles and operations associated with signals. For the analysis purpose, this knowledge is must. Like from electronics and telecommunication point of view, we need this analysis for designing the transmitters, receivers, or maybe encoders, encryptors. We need this knowledge when we deal with the digital signal processing, where image processing may be required, or robotics, or radar based some sort of systems, or maybe biomedical based some systems where the various activities which are analyzed with the help of some spatial medical signals like ECGs and EEG and MIR related MRI related signals and all those things. So in all these aspects, from all these say fields as far as considered, we need to know how exactly various operations are performed, and what are the mathematical tools and operators and techniques with the help of them we can analyze the signal. And in the disciplines of signal and image processing nowadays, even the advanced technologies from the field of deep learning, machine learning, uh, are also playing very important role. Neural network. So many things are there which are possible with this, and therefore you should have the fundamental knowledge or the basic background for this particular field or area. So from students point of view or career point of view, if we speak, then definitely you can work as a developer in this field, as a software or hardware engineer in the area of signal processing, such as audio, image, medical, remote sensing, Number of companies are working, no doubt, from communication point of view, even for antenna design, or maybe for the transmitter or receiver design, or maybe any other kind of assistance, as a engineer, when you want to when anybody wants to provide, or a company wants to provide, so that also requires some sort of such fundamental knowledge. No doubt, based on the respective requirement, it differs, but it is helpful. So you have a number of options, and you can work in different companies. As far as software field is considered, there are a number of softwares which are handling signal processing applications, mainly image and speech processing. MATLAB is one of the most popular uh, platform, the most powerful as well, where you can work with that, and as a developer, you have definitely a great opportunity. From higher studies point of view also, among all the modules which are covered under entry level exams like GATE, as far as considered, this course is also having 10 to 15% weightage. The way the GATE curriculum is divided in various, say, we can say modules of electronics and communication engineering as a course. So there is a 10-15% weightage for digital design, for analog design, then for aptitude, then mathematics, and then control system and electromagnetics, uh, your devices, and other, say, uh, design part. Same fashion, there is a 10 to 15% weightage for this particular course, that is signal system as well. So there also, this particular knowledge is required, mathematical treatments and or analytical approach. So that's why we need to study uh, basic definition associated with signal, because as the terminology indicates, there are two things which we want to comment as far as first unit is considered. First part is signals, and the second part is systems. In this presentation, I'm just giving a small overview kind of a thing. So signal is a function of one or more variables that conveys information about physical phenomena. Signals are functions of independent variables, especially, that is, we work in time domain. A physical signal is modeled using mathematical function. These three basic things you should remember. There are a number of signals which we in our day-to-day life come across, and not necessarily as an engineer, but general course also. Various domestic appliances we daily use. So there are a number of signals, like there may be a electrical kind of a device, like a fan may be there, regulator may be there, inverter may be there, or television, or mobile, or computer, or washing machine, or mixer, grinder, or a number of such applications, or even nowadays all these vehicles, automobiles sector as far as considered. So everywhere there are different types of signals. They may belong to categories like electrical signals are there, electromechanical signals are there. In general, if we speak, then acoustic signals are there in the form of audio or speech. Video signals are there. So biological signals are there, maybe like EEG, or ECG, or heartbeat, or anything. So all these are different types of signals. As far as systems are considered, there are also a variety of, say, we can call it as an entity, or a device, or something as a operational kind of a, say, black box, we can call. And this may take any form, like the system may be having single input single output kind of a relationship. It may be having many inputs, single output. It may be many inputs, many outputs, or it may be single input, many outputs. So four basic forms are there, and your system may take any form. The system is nothing but an entity which is responsible for manipulating n number of signals, or maybe a single signal. It is going to fulfill some requirements. It is going to provide some service. It is going to accomplish a function, and that is going to definitely produce, or going to yield some new signal. So input output relationship is to be modeled using mathematical equations, and some processes are involved. So we must know those things as a part of this particular course. We want to study these responses of the systems to signals. System may be made up of physical components, like it may be hydraulic or mechanical or electrical or any other, or maybe an algorithm that computes an output from input signal. Say for example, here I have written Vt is equal to Rit. So Vt is a voltage which is produced, or we can say that it is excitation. Either way we can talk about. We have excited some circuit, that is in that circuit there is a closed loop and there is one resistor present, and because of that excitation or stimulation which is acting as the input or voltage, it is producing some current according to Ohm's law. So that is the kind of a say process which is involved with this small electrical circuit. In association with that resistor, when we connect a capacitor or when we connect an inductor or when we connect them in series or parallel, or with them if we add any mm, operational amplifier, that is op amp, or if we add a diode or a transistor or a switch or a relay or motor or an unlimited. So anything when we club together to form a kind of a electrical circuit, and if it is excited by some means as an input, then definitely it is going to produce some output or a response. That response may be steady state, it may be forced, like transient, anything may be there. We can't uh, as per our requirement, we are going to design it and it is going to respond accordingly. So n number of such systems are there. For example, mass spring system is a popular one, as an input as a force and output is a displacement of that. Automatic speaker recognition, say for example, speech is the input and output is the identity. Anything which we can describe with the help of a known deterministic form as a mathematical model we can interpret. So that itself is represented. Applications as far as consider of signals and system, as already in the beginning I mentioned, there are unlimited say areas. So for example, 2 3 I have listed out here, like acoustics is restore speech in a noisy environment such as cockpit, say for example, is the requirement. Transmission in mobile phones, GPS, radar, sonar, a number of systems are there, like multimedia where we want to compress and store data. Biomedical applications are there where we may want to analyze some sort of signals like ECG and going to monitor them, or we want to get some sort of a diagnosis out of that. So that is required. Medical imaging is also one emerging field in biomedical engineering. So there are also a number of such processes involved. Applications like say for example, using your biometric, there are applications. As far as processes, various processes which are carried out in the industry, so like associated with various parameters, that may be a temperature, that may be a velocity, that may be force, that may be any other thing. So electromechanical systems are to be designed, automation based systems using PLCs are to be designed. There are a number of control inputs and inputs, and then accordingly there will be output. The system may be with or without feedback, so it may need some sort of say feedback, and based on that it is going to change or predict something. So recursive systems may be there. So there is no limit. N number of such systems are there. In general, if we talk about examples, once again just I have listed it, nothing very different, but in general, you have electrical signals, you have acoustic signals, you have video signals, biological signals. As far as your computer is considered, then huge number of say input signals and output signals are produced. Image is one of the most popular, like audio video is one of the most popular. So like that, you can have a representation of that. So it, since it is a function of a particular say variable, it is a relationship between the dependent and independent variable. So that may be 1D or 2D or 3D, like 1D is best with respect to time, or 2D is with respect to space, and 3D is also again in free space. So that is going to become more and more complicated. It may be in nature continuous time, that is analog in nature, or discrete time, that is digitized one, decimated one, or it may be random in nature where you can't give any sort of a prediction in advance. It may take any form, real time signals like uh, stock market, if with that all whatever is today's and next day, like we if we want to plot, so it will be random in nature many a times. Okay, or maybe weather report or maybe anything. So nowadays there are optimization and prediction algorithms. With the help of them, some sort of deterministic results are produced after analysis, but in general they are having their own original random form. So that is also there. Now we will talk about basic categories. Just as a part of this small presentation, I've clubbed them. Like basically signals are classified in general as, first thing, we are interested in knowing that whether they are continuous or discrete in nature. That means whether they are going to vary or exist or going to behave or need to be monitored and processed and analyzed in analog way, that is in a continuous domain, time domain, or whether they are discrete in nature. So this is the first thing which we need to classify as far as our application is considered, our design is considered. So that's why continuous time and discrete time, these are the two categories or the two main classes. So maybe anything. So for example, I have shown one small signal stroke which is continuous in nature. We want to view, we want to know that continuously what is happening. So this is continuous time signal. Whenever we are interested in discrete intervals, like say for example somebody is telling you that you plot a graph or develop a system which will give you outputs at regular intervals, that is I want today, then next day, then next morning, next morning, next morning, like that. So daily report I want, by the end of the day I want. I don't want continuously, I want only in this hour, I want only for this particular time instant. So if it is decimated, if it is in a discretized form, if it is discrete in nature, digital in nature, we call it as, it is digitized. Okay, so many such signals or many such applications where we are actually dealing with the relationship between analog and digital. So though we say that the whole universe is analog in nature basically, but all high speed computational machines are digital one. They have been digitized so as to reduce bandwidth, so as to reduce redundancy, latency, n number of figure of merits are there. So therefore, there is a growing interrelationship between such DT signals and signals, that is continuous time signals and discrete time signals. So that analysis is also needed, or a kind of a say applications where both these are taken into consideration. Communication applications especially. So definitely when we do it digital communication, we are going to pulsate it, discretize it, and again while transmission along the channel, we are going to convert it with the help of our say carrier modulation technique in the analog form. So originally it is AM, FM as an analog communication. Then we made it as a PCM, PPM, PWM, like that, as a digitized one. And then again when we send that along the channel uh, over antenna, so at that time again we are making it continuous one. So like that. Second category is whether it is periodic or not. This is also second very important feature or issue. Like we want to know or we want to analyze the signals which are periodic in nature for some applications. Somewhere they are aperiodic in nature. The signals which are repeating themselves at regular intervals or which are following the mathematical identity as x of t is equal to x of t plus t, or in discrete domain x of n is equal to x of n plus n, where capital N is a fundamental period, capital T is also fundamental period. That is the period with which it is going to repeat itself. So such signals are known as periodic signals, uh, and signals which are not repeating themselves, those are called as aperiodic signals. So here we have uh, next thing, that is once we know that whether it is periodic or not, or once the stroke is known, we also are very much interested in knowing whether their behavior is even or odd, because whenever some sort of a reversal mechanism is going to happen, reversal or inverse is going to occur, or whether there is an inverse existing or not, we want to know. So at that time definitely evenness of the signal plays very important property or feature. So signals by definition mathematically, if x of t is a signal, Then if x of t is equal to x of minus t, that means its mirror image is same, its reflection is same, then it is even signal. If it is not, then it is odd signal. So same thing is applicable for continuous time as well as for discrete time. As far as even and odd signals are considered, then by definition even signal is calculated or estimated as x of t plus x of minus t divided by 2, and odd signal is estimated as mathematically using the relationship x of t minus x of minus t divided by 2. We will give a little more focus, few solved examples I will share with you, and at that time we will make some mathematical comments or the approach associated with this even and odd concept. In this session only I am introducing. Then there may be a kind of a symmetry related classification, that is right sided signal and left sided signal, positive signal or negative signal. So the way it is shown, if it is existing for t greater than 0, it is existing t less than 0, like that. There is one more category where the, or we can call them as an unipolar or bipolar signals, or either way it will be unilateral or bilateral. So with respect to x axis, when we talk about positive and negative half, so it is related with unilateral and bilateral. And when we talk about y axis, whether the values are returning you positive or negative answer, so based on that, it is with respect to y-axis we call it as unipolar or bipolar. If plus minus both way it is, then it is bipolar. If it is only plus, then it is unipolar. Okay. Then the signal can be bounded or unbounded depending upon the stability of the system. So that is directly associated with system. So if system is producing output which is unbounded, which is fluctuating, or which is going to end up something, going to burst, going to burn, going to make down the system, that is not a stable behavior, that is unstable. And the signals which are producing stable output, so those are stable signals, or systems are said to be stable systems. So bounded corresponds to kind of a finite answer, somewhere known, somewhere it is going to stop, suspend, and going to be happy with the finite answer. The systems which are producing infinite, not converging, but their divergence is observed, such signals are unstable signals. Real and complex is also category. So mathematically, whatever mathematical model we are used to design the associated system, and whatever it is producing, if it is a purely real in nature, then it is called as a real signal. But if it is having some imaginary component, then it is called as complex signal. So real and complex is also one category. Again, based on the dimension, that is dependency, there are two categories. One dimensional, it is a function of single variable, and when we talk about multi-dimensional, it is function of multiple variables. Like basically, as far as speech and image is considered, speech is associated with only time, so it is one dimensional function of time, but image is associated with function of x and y because it is a coordinate. So pixel coordinate system, it is existing, so therefore it is said to be in space, it is represented, or even sometimes if it is a color, then it is RGB. So therefore it is multi-dimensional. Most of the times we focus on one dimension. Continuous versus discrete, already we mentioned. Analog versus digital, which is very close to continuous and discrete. Deterministic and random, the signal which is taking some mathematical form, which we can express, which we can describe, which we can interpret using known mathematical identities. Like it is a sinusoid, it is exponential, it is parabolic, it is ramp, it is triangular, it is square, it is staircase, anything it may be, but it is deterministic one. It should take deterministic form. Or it may be hybrid also. 2-3 operations are say operators are clubbed together, but still it should be deterministic one. Then fine. But you can't write ECG signal. What is a pattern? Can be described with a single equation? No. Is it possible to identify interrelation between the various instants and that ECG signal can be written in one equation? No. So therefore it is random signal. Okay. So there may be deterministic or random. There will be a periodic or aperiodic, already I mentioned. So when it is repeating itself, then it is a periodic. You can have, we will have a little more focus on this also, and otherwise it is a periodic if it is not repeating. causal and anti-causal. So that means existence wise we are classifying less than T0. If it is, then it is non-causal. If it is 0 for T less than 0, that means in the negative half there is no signal. All unilateral signals, positive sided signals, are causal. The signal which is lagging behind in the negative half, so that means the future values are yet to occur, they are yet to appear, so those signals are non-causal signals. Even odd, already I mentioned, e raised to minus t, x of t and x of minus t, so that is reflection, and when it is clubbed together and divided by 2, it is giving you even part, and when it is subtracted and divided by 2, it is giving odd part. So we will solve 2-3 examples on this also, even signal and odd signal. A signal is a combination or maybe pure even or pure odd. As far as when signals are combined together, then one even, one odd, if it is multiplied, then it is giving you odd. Both odd multiplied giving you even. One even, another is also even, giving you even. One even, another even, if you added, even. One even, another odd, if it is added, then it is giving you neither. So you can't make comment in advance. Rather, it is not pure odd or pure even, it is mixed, and odd plus odd is going to produce. Finite versus infinite length may be also a category, that is if it is which is related with bounded. So the one which is bounded one, that is the finite length, and another one which is unbounded, so that is having, maybe having infinite length. And one more is energy and power. So here also there may be a category, that is uh, instantaneous power of a signal equivalent to instantaneous power over one resistor, like that for electrical signals. For example, we define, so total energy and average power. From signal system point of view, in general, these are some specific comments. Signal is an energy signal if its energy is finite. Signal is a power signal if its power is finite. Very important. Energy signal has zero power and power signal has infinite energy. Periodic signals and random signals are usually power signals, but signals that are both deterministic and aperiodic are usually energy signals. Finite length and finite amplitude signals are energy signals. Even mathematically, we will interpret for energy and power, and we will solve some examples based on that also. So these are the, here we have classified signals based on continuous time or discrete time. Signal may be either even or odd. Signal may be periodic or aperiodic. Signal may be having finite length or infinite length. Signal may be bounded or unbounded. That is, it is producing bounded output or unbounded output, that respective system. So accordingly, it is bounded or unbounded. Or a signal may be energy type or a power type signal. So whatever is your requirement or whatever is your system, so the way it is producing, we have to accept and we have to analyze them. So these are some basic categories as I mentioned. Once again, I am repeating: continuous time, discrete time, first thing, based on time domain behavior. Then there may be, I will one by one I will go through continuous time or discrete time to summarize. One dimensional or multi-dimensional dependency. Third thing is, it may be real or complex mathematical interpretation. If it involves imaginary part, then complex. If it is only purely real, real. Next thing is, it may be deterministic or random. So the one which is having a proper mathematical form is deterministic. The one which is not having any such specific form, that is non-deterministic or random. The signal which is having periodic nature, that is repeating itself, or it may be aperiodic. Signal may be even or odd. Signal may be causal or non-causal based on its appearance or occurrence, less than t less than 0 or t greater than 0, whether it is in the right half or in left half. Accordingly, it may be causal or non-causal, or signal may be energy or power. So these are some of the categories in which signals are classified. Thank you. Here I have just mentioned signal energy. In detail, we will go through it. That is, what exactly is the power, how it is calculated, or how energy is calculated, and all that part. By definition, we have to proceed further. and average signal power also you can mention, and based on that some decisions you can take. So here are some comments. As far as power is considered, time average of signals with infinite energy, signal does not go to zero as time goes to infinity. This you have to remember. Time average of amplitude squared, mean squared value we are taking. Square root is root mean squared value of signal. Power signal must have infinite duration. Periodic signals are power signals with finite energy in period. Random signals are power signals. Power of energy signal is zero and energy of power signal is infinite. So these things you need to remember. Thank you once again.